They come off, they hit the bell, they move to the next one until you hit the end of line resistor. That's what these blue guys are everywhere. If you have no devices on a circuit, the end of line will be installed directly at the panel. If you ever see this, it needs to be noted, because if this now is disconnected anywhere, you'll never get a trouble. Basically what the panel does is it looks for that resistor all the time, and if it can't see it, it's open and you'll have a trouble. So your fire alarm panel usually comes with 4 NACs standard. You can either use it to ring 4 circuits, you could use it to be a trigger for a NAC expander. This is what happens when you have too many circuits and there's too much power drawn. You have to add additional boosters. Same thing from there, that just gives you 4 more circuits with the end of line installed here. If this is all you have and you pull the 4 NAC circuits off of the fire panel on a conventional fire panel, this should be all you have to do. There shouldn't be any extra steps. What Kaylin ran into yesterday is an addressable fire panel that has all the same NAC circuits on it. But what they do is these guys will be local. So from the fire panel, there will be 4 circuits nearby that he can go out and ring. You pull all of these and you think that you're good. Well, on an addressable panel, they'll have SLC voltage that will come down, and they can hit an output module anywhere in the building that they can tap off of the SLC circuit that's ran all over anyway. So instead of having to run a wire from the basement to the 11th floor in this example, you just tap off of the nearest addressable device over to an output module, drop that down, and now that's your trigger. And so this is what Kaylin ran into yesterday. He went and pulled this wire because there was only one on the panel in use, and he thought that was good. But then there was still one of these. If you ever come behind me on a job and we find these, I will write all of the module numbers that need to be disabled on the door of the panel in a chalk pen on the label, and then write a note that just says this is doors, this is output circuits, this is whatever. These are what need to be disabled. Again, if you come to these NAC circuits, you have 2 different options. Excuse me, back down here. You could either pull all 4 of the NAC wires individually and have 4 troubles on this NAC, or you can just pull one of the input wires, because if this panel never sees the input, these wires will never change state. So if you go to a NAC expander, you don't necessarily have to pull all 4 circuits. You can just pull 1 wire. Trying to think about what else there could be. Is there any other questions about bell circuits, NAC wiring? Does this make sense? This is just like a bell circuit, but instead of hitting devices, we're hitting NAC expanders. These are a pain in the ass because they will all report back to the fire panel as a NAC-free trouble. This is how Madrona is set up. If you ever get sent out there, they'll have an output circuit that just says floors 1, 2, 3, 4 outputs. Then you have to go and look at all 4 or 5 of the panels and see which of these is actually in trouble. So it's actually basically supervising 20 NAC circuits with 1 because they have it properly wired. And so you'll see this where it'll come in, hit 1, the commons will be shared, and then the positives are split, and this is how they get their supervision, is if any of these devices open, now this will open, and now NAC 3 can't see the resistor over here. But if all of the circuits are normal, the batteries are good, the AC power is there, they will all be closed, and the panel will be able to see the end of line resistor. Basically that's it. So just realize that when we do this shit, you're gonna ring out the building sometimes, and this is why we do it. It's not the end of the world. If the service was scheduled, they should know that this could happen. It shouldn't be a surprise.